So yes, students have also responded. Yes, sir. Very good. So now let us start from where we were in yesterday's class. Okay, and in yesterday's class we have completed up to the discussion about the different theories that we have. Okay, so we will continue from there itself. All right, we have already completed, or we have already basically started the discussion that movement of the surface of the earth, right? Movements of the surface of earth. Okay, and when we say surface of earth, we have already seen continents and ocean floor, and then we saw that these movements were first given hinted by some scholars like Abraham Ortelius and Antonio Pellegrini. Okay, and then we saw theories. Okay, and in the theories we saw continental drift theory, then convection current theory, then sea floor spreading theory, and then plate tectonic theory. Okay, so these are the different theories that we have already written about and we need to take up. Okay, so first we start with continental drift theory. Okay, so today's class we start with the continental. It's cold in this part of Himachal, so I need to just continental drift theory. Okay, given by Wegener, Alfred Wegener. (1912). So given by Alfred Wegener in 1912. This is the theory that we need to take up. Okay. So when we talk of this theory, the Alfred Wegener theory, first we have to understand why he gave the theory. Okay. Why he was prompted to give this theory. Okay. What prompted him to give this theory? First part. Okay. So why he gave this theory. First, the why part of the story. Okay, कि दिया ही क्यों उन्होंने ऐसा theory. So what, or rather, what made him give this theory? Okay. So are these scholars' name important from UPSC point of view? Yes, UPSC has asked questions around them. और अगर छोटा मोटा ऐसा चीज है जो कि एनसीईआरटी में दिया है, अगर आप उसको भी पूछोगे सर आर दीस पॉइंट्स इंपॉर्टेंट, एनसीईआरटी में गिवन एनीथिंग इज इंपॉर्टेंट. दे कैन आस्क यू एनीथिंग गिवन इन द एनसीईआरटी एंड यू कांट से ओहो. ठीक है, so you should be in a position to remember why he gave these theories. So was Alfred Wegener a person who was trying to study the movement of the continents, right? Or was he trying to study anything related to geology? Geology means earth's surface and all. No, Alfred Wegener was not a scholar who was trying to study the movement of continents or geology or the land, etc. No, he was a person who was studying climates of the past. Okay. So Alfred Wegener was a scholar studying the climates of the past. If you want, you can write this one line. Okay. So he was a scholar who was studying the climates of the past. Right? Please do note this line in your copy. He was a scholar who was studying the climates of the past. Scholar who was studying the climates of the past. And past within bracket, hundreds of millions year ago. Climates of hundreds of millions years ago. Past means not 1000, 2000, 5000 years. Hundreds of million years ago. Full stop. Bracket close and full stop. For this, he used to, collect, fossil evidences, of plants and animals of those periods. Plants and animals of those periods. Plants and animals of those period from different parts of the world. Plants and animals of those period from different parts of the world. Because plants and animals grow in a region, plants and animals grow in a region based on the climate existing in that region. Based on the climate existing in that region. Okay. So we understand that he was a person who was studying the climate of the past, and in trying to understand the climates of the past in different regions in the world, he used to collect the fossils of plants and animals of those period. Okay, fossil means the remains, the dried remains of the plants and animals of those period. Why? Because once you get the plants and animal fossil of that period, from that you can make out what type of plants and animals were growing, and plants and animals grow depending on the climate of the region. So from the plants and animals, he could understand the climate. For example, if you go to the hot desert, you will find camels. If you go to cold mountains, you might find snow leopards. Okay, I hope you get it. If you go to the polar region, you will get the polar bear. So something like this, and the same way plants also. Okay. Now, write down next paragraph. While doing these studies, he came across some very confusing evidences, and conclusions. He came across some very confusing evidences and conclusions. Now, what were these very confusing evidences and conclusions? I will try to show to you in the form of a diagram. Okay. Right. Very confusing evidences and hence conclusions as explained below. Okay. As explained below. So now this is the earth, and suppose this is the pole, south pole, north pole. Okay. Now we understand that the regions which are closer to the poles, okay, regions which are closer to the poles are generally colder regions. So we can say that this kind of a region which is closer to the pole is expected to be a colder region on the earth. Same way as here. This region we expect to be colder region. Okay. And I'm showing expected to be colder. I'm showing this colder thing by a colder. This region we expect to be colder. Okay. Or we know that these regions are generally colder regions. Whereas when you go to the polar regions, when we go to the regions near to the equator, there we know that these regions near the equator are generally expected to be warmer regions. Okay. Regions near the equatorial region are expected to be warmer. Okay. Or we know that these regions are warmer. Okay, something like this. I just made the earth with the colder and warmer regions. Okay. Now let us say that Wegener went to some continent. Okay, like this. So he went to a continent. I'm just making a model continent. Don't ask me, sir, which continent is like this square type. I'm just making a sample continent, right? And in this continent, you can see there are two types of climatic regions, the colder climatic region and the warmer climatic region, right? So colder and warmer. So let us say this region we call as 1, this other region we call as 2, right? The colder and the warmer climatic regions. And I would expect you to draw this diagram also simultaneously. That will help. ठीक है, तो ये साथ साथ बनाते भी रहिए. Okay. So colder and hopefully you are drawing. Right, so warmer and colder regions, right? Now assume that Wegener went to region 1 to collect on the continent. He went and collected the fossils of plants and animals in region 1 as well as region 2. Okay, so he went to these regions and he collected the fossils. Now based on the fossils, what do you expect? Now first give me the expected. What do you expect? What type of region should be region 1 and what type of region should be region 2? You can speak in terms of warmer and colder, okay, or polar or hotter, right? Equatorial, tropical, something like this. You can talk like this. Region 1 can be warmer or colder, region 2 can be warmer or colder, or you can say sir polar or equatorial, tropical. Equatorial, tropical is one word. Okay, so what type of region do we expect? What kind of region do we expect? Region 1 and region 2. I need the answers from you. So just give me the answers quickly. What kind of regions do we expect these regions 1 and 2 to behave like? Yeah. What kind of region do we expect? So the answers have started coming in. Region 1, we expect them to be colder region with flesh. Okay, but I'm not asking which region, what type of body will you find. I'm just asking what type of region should we expect. I'm not asking that flesh or skeleton thing. Sri Krishna, Sri Srisha Siri. I'm not asking that. I'm asking what type of region the region should behave like. Region 1 should behave like what kind of region, and region 2 should behave like what type of region. Tropical and equatorial region. श्रुति किसके बारे में बता रहे हो श्रुति? ऐसा तो मुझे नहीं समझ में आएगा. Incomplete answer श्रुति. Okay. What kind? So I'm getting most of the answers are right. Okay. So I'm getting most of the answers are right, but some answers need to be corrected. So region 1, I'm getting the answers. So region 1 will behave like colder regions and region 2 will behave like warmer regions. Okay, देखो मतलब जितना मैं पूछता हूँ ना आप उसके आगे जाकर के आंसर जबरदस्ती करना चाहते हो. गिव मी द आंसर ओनली टू द एक्सटेंट दैट आई एम आस्किंग. So region 1 will behave like polar regions and region 2 should behave like warmer tropical equatorial region. Very simple answer. है ना? It isn't a very difficult question. Right? So region 1 colder and region 2 warmer. This is what we expect. Okay. Now please see what did he get in terms of his observations. So you can write the next line. The very confusing हमने लिखा है ना, very confusing or very contradicting evidences he got from. Right. So you can write that Wegener while collecting. Now write this down. Wegener while collecting the fossil evidences. Wegener while collecting the fossil evidences from the present day, polar subpolar regions of the world, like one, polar subpolar regions of the world, present day polar subpolar regions of the world, from the present day polar subpolar regions of the world, underline present day polar subpolar regions of the world, got equatorial tropical within bracket hotter region, bracket closed, type of fossils of plants and animals. Of the past. Types of plants and animals, fossils of plants and animals of the past. Within bracket tens or hundreds of millions of years ago. Tens or hundreds of millions years ago. Right? 100, 200 million years ago, something like this. So 50, 70, 100, 150 million years ago. So this kind of, right? Full stop. And when he collected fossils from the present day means in the last 100 years, 50 years, present day hotter equatorial tropical regions within bracket like region 2 in the diagram, present day hotter tropical equatorial regions, within bracket like region 2 in the diagram, he got fossils of polar subpolar type of plants and animals of the past again within bracket tens or hundreds of millions of years ago, bracket closed. Tens or hundreds of millions of years ago, bracket closed. Okay. All right. Now I have added one line in this diagram, present day continent position. Okay, so this is the present day continent position, right? And in that continent, 1 and 2 regions we have seen. Okay. So I would expect you to write this line, present day continent position. ये लिख लीजिए in the diagram. Right. So what did he get? In the present day polar regions, colder regions, he got fossils of hotter region, equatorial tropical plants and animals of the past. That means in this region, in hundreds of millions of years ago, equatorial tropical type of plants and animals were living. Right. So in the present day polar region, if you find a fossil of camel, let us say, okay, fossils of camels, or you find coconut tree in the polar region, right, that millions of years ago coconut trees were growing in the polar region, or mango was growing in the polar region. So that kind of evidence. Okay. And in the present day continent, this region, equatorial tropical hot region, for example, you go to places in South India, and he did collect, get the samples. So from southern parts of India, he got evidences of glaciers existing in the hundreds of millions years ago. Okay, something like this, glaciers or glacial animals and glacial plants. Okay, so you can say that kind. So this kind of evidence he got. Okay. Now write down next paragraph. This was very confusing for him. That how in the past the climates in these regions were so different and nearly opposite. Climates in the past were so different and nearly opposite. Means colder region, present day colder region earlier had hot climate, and present day hotter region earlier had cold climate. Also. Right? So, what explanations were possible? Okay, possible explanations for this. So let us see. So possible explanations. So what were the possible explanations for this? The possible explanations that he had or he could get was that climates or climatic regions on Earth have changed. Climatic regions on the Earth have changed. This is one. What does that mean? As per this diagram, it means that the present day colder regions were earlier hotter regions, which means the present day polar regions were earlier equatorial tropical region, and the present day equatorial region, the hot middle region, which where we are, so this hotter region was earlier polar kind of region. Okay, so this present day equatorial region was earlier polar regions, and the present day polar regions were earlier equatorial tropical type of regions. Okay. So this is what it means. We can write climatic regions on Earth have changed, which means, please do write this, which means that present day regions near equator, near equator and tropics, were earlier having extremely cold polar climates, whereas the present day regions near the north and south pole, were in the past having extremely hot equatorial tropical climate. Also. But we know that climate on the earth in different regions is due to different amount of sun's heat, reaching different parts of the world, different amount of sun's heat reaching different parts of the earth. Okay, just give me a moment. I need to put this off, otherwise these people will go on disturbing. All right. Some people do not understand, despite of, even if you decline the call, they will not understand that they should not be calling again and again, right? Calling on right time is, in a right manner. You should have so for calling also there is a specific kind of behavior which is expected. Like for example, yesterday night there was a student who called. I got a call around 10:18. Okay, and I generally sleep by 9:30. And I generally tell you people also not to call, too late. So he called around 10:18 in the night. Okay. And he called and he asked, sir, I am an old student of Vision IAS and I have some doubts to ask. Can I ask you? Now, I hope everyone understands untimely call, right? रात को 10:15 बजे क्या डाउट खड़ा हो गया जो पूरा दिन नहीं था, और है भी तो you should be calling, at a appropriate time, right? So calling behavior. So I told him the same. Is this the right time to? Do you think this is the right time to call? Anyways, come back. So what were we saying? That climate on the earth is mainly due to different amount of sun's heat reaching different parts of the earth, right? This much we have written. For example, the present day polar regions receive, for example, the polar regions receive less sunlight, hence they are colder. The polar regions receive less sunlight, hence they are colder. Polar regions receive less sunlight, hence they are colder. And equatorial tropical regions receive more sunlight, hence they are hotter. Equatorial tropical regions receive more sunlight, hence they are hotter. But the Earth's rotation and revolution, has remained nearly as it is, since its formation. Earth's rotation and revolution has remained nearly as it is since its formation thousands of millions of years ago. Since its formation thousands of millions of years ago. Hence, because the Earth's polar region and equatorial tropical regions, Earth's polar regions, North Pole and South Pole, and equator and tropical regions have not interchanged their positions. It's not that the polar regions have become equatorial regions by turning of the earth and the present day equatorial regions have become polar regions by turning of the earth. Okay, have not interchanged their positions in any way. Hence, such drastic climate change is ruled out. Such drastic climate change is ruled out. It's not possible that such drastic climate change would have happened on the earth, that the present day polar region has, become equatorial tropical region pointing towards the sun, and the present day equatorial region, right, parts of Africa and all, they have, all of a sudden the earth has turned and they have become polar region. So it is not possible. You get it? Okay. So this is what is stated. All right. Clear? So then the other possibility, that Wegener thought of the other possibility that Wegener thought of was that the continents have changed their position. The continents have change their position. The continents have changed their position. That the continents have changed their position over hundreds of millions of years. Change their position over the past. Continents have changed their position over the past. Okay. Now, what does this mean? This means that Wegener said that it might be possible that the present day continent position, which is here, in the past, the same continent was placed somewhere here. Same continent was placed somewhere here. And then these two regions that we are talking of, 1 and 2, past position of the continent. Past position of the continent. Okay. So now he said that if we go by this, then region 1 we are saying colder. Sorry, region 1 we are saying had what evidences? Hotter evidences. Hotter evidences, and region 2 had colder evidences, which was confusing. But if you see now, if the continent was here, then region 1 would obviously give you hotter and region 2 will obviously give you colder. So when the continent was here hundreds of millions of years ago, then region 1 animals were in the hotter region, so their fossils are also of the fossils are of the hotter region, plant and animal, and region 2 in the past hundreds of millions years ago was in the colder polar region. Hence the fossils in the region 2 hundreds of millions years ago are also of colder kind of plants and animals. Okay, do we get it? So this is what Wegener's theory tried to say. Clear? So he said that in the past, position of the continent was somewhere here, and because of that, the continent at that time in its hotter region had hotter plants and animals, colder region colder, and the same ways, right? And for this, he did get some support in the form of the previous statements given by Antonio Pellegrini and Abraham Ortelius. Okay, so he did get some hint that okay, some scholars have already said in the past, right, before him, that continents might have been together, okay, or the continents seem to fit. So he said if they are fitting, that means they were together. So maybe, right? And then he focused on this part. He said rather than the whole earth, doing a very awkward kind of turning and interchanging its positions, rather than that, the whole earth doing, it is possible that maybe the continents on the earth might have shifted. Okay. And he did get some hints, and so you can write this. Wegener, hence, write down, Wegener hence focused his research more. Wegener hence focused his research more on the movements and shifting movement and shifting of the continents. Movement and shifting of the continents. As he got some hints, from the previous studies, some hints from the previous studies of scholars like Abraham Ortelius and Antonio Pellegrini, who had earlier said that the continents seem to fit together. Okay, continents seem to fit together. Clear? So now, what did he state in his theory? What did he state in his theory? What did the theory say? The continental drift theory, what did the theory say? Okay, so we'll try to understand what did he say through his theory. Okay, so the statement of Wegener's theory, we will try to understand through diagrams. And you people have already have the continental drift PDF with you, so I would expect you to keep it open, right? So now please see. Please watch the video yourself, Sumit. Yeah. So what did Wegener said? His theory in points. So we'll write what did the theory say in points, right? You can write it point wise. 1. He said 1, the first. Point 1. 250 million years ago, please write this. And because these are simple explanations, so there is nothing too scientific in this, nothing too deep to understand. So you can write and understand simultaneously. 250 million years ago, all the continents, 250 million years ago, all the continents were together. All the continents were together as together, joint as one supercontinent 250 million years ago. All the continents were joined together as one supercontinent called Pangaea. The spelling you can see here. Pangaea. Surrounded by a super ocean called as Panthalassa. Supercontinent surrounded by a super ocean called as Panthalassa. One word, Panthalassa. So now, which are the in this supercontinent? All the continents were joined together, which you can make out still while looking at the supercontinent. For example, you can see, I'll go on writing on this supercontinent just to help you. This lower one is the Antarctic region. Antarctic. I hope everyone can make out that this lower one is Antarctic. Okay, this is Australia next to it, that side. Australia. This is India. India Peninsula. India Peninsula. Right? The Indian Peninsula. This one. This block. This is Africa. This is South America. This one is North America above. This side. North America. And this is Europe plus Asia. So these were all the continents which were joined together as per his theory when 250 million years ago. You don't have to remember these words, Permian and all. These are the names of those geological period. UPSC has never asked question around the name of the geological period, so you should not, focus on those names. You should just know the period. So 250 million years ago, this was the condition. Then next, second point. 200 million years ago, the Pangaea broke into northern part. Pangaea broke into northern part known as Laurasia. Pangaea broke into northern part known as Laurasia, and southern part, and the southern part known as Gondwana land. The ones who have read the NCERT, the spellings are there. Here also, Laurasia and the southern part known as Gondwana land. Right? India was also part of the Gondwana land, Australia, Antarctica, all this was the Gondwana land, Africa, South America. Okay. And the southern part known as the Gondwana land. Full stop. Also, Laurasia started drifting northward. Laurasia started drifting northward during this period. Laurasia started drifting northward. So during 250 million years ago, Pangaea broke into northern part Laurasia and southern part Gondwana land. Also, Laurasia started drifting northward. Itna bola hai maine. This much I have said. Laurasia started drifting northward. which led to oceans filling the in between period, oceans filling the in between region, which led to oceans filling the in between region, this broke from this. So in between region, oceans filling the in between region, known as Tethys Sea, Tethys, Tethys Sea, known as Tethys Sea. Oceans filling the in between region, known as Tethys Sea. It broke around 200 million years ago, right? Known as Tethys Sea. Then third point. Around 145 million years ago, 145 million years ago, written here, 145 million years ago, as Laurasia continued to drift northward, as Laurasia, 145 million years ago, as Laurasia continued to drift northwards, Laurasia continued to drift northwards, comma, the Gondwana land also started breaking further. Gondwana land also started breaking further. And its different parts such as South America, Africa, Indian Peninsula, and Australia also started drifting northwards. Okay, so Gondwana land also broke and its parts also started drifting northwards. Then, fourth point, 65 million years ago, 65 million years ago, 65 million years ago, as all these parts continued to drift northward, 65 million years ago, all these parts continued to drift northward, comma, the western continents, North America and South America, also started drifting westwards. North America and South America also started drifting westwards. also started drifting westwards like this. So North America and South America, they were drifting northward, but they also started drifting westwards. Good stuff. 0.5. 0.5. And this way, all the continents have reached their present position. And this way, all the continents have reached 0.5. And this way, all continents have reached their present position at present day. This way, all continents have reached their present position at present day, while they still continue to drift. While they still continue to drift. As per Wegener's theory. Still continue to drift as per Wegener's theory. Okay, so these are the 5 parts or statements of the Wegener's theory. Clear? So 5 statements given by Wegener's theory. Right? Now, so once he stated this, right? Once Wegener stated this, what evidences did he give to support his theory? So next part, we have written the statements. Next is evidences given by Wegener to support his theory. Okay, evidences given by Wegener to support his theory. So what evidences did Wegener give? I'll write on the board itself. You can copy from here. So the subheading is evidences given by Wegener in his theory. Evidences given by Wegener in his theory. Because if you are saying something so drastic that the continents are drifting over the last 250 million years, people will say, what is the proof? So Wegener had to give the evidences also. Okay. Break will come at 10:30. Okay, don't worry. Not before that. एक घंटा में ब्रेक दूंगा तो हो गया क्लास. Alright, इतना जल्दी ब्रेक नहीं मांगना है. Okay, so come back. So what evidences did Wegener give to support his theory? So write down. We'll write evidences also one by one, and I'll go on explaining also the evidences. Okay. So the name of the first evidence that he gave, as given in your NCERT, is jigsaw fit. Jigsaw fit. Right? Also matching of the continents. Jigsaw fit or matching of the continents. Matching of continents. Right? Matching of continents. So he gave the same evidence that was given by Abraham Ortelius and Antonio Pellegrini. Right? That was his first evidence. The first evidence given by Wegener was also the same as given by Antonio Pellegrini and Abraham Ortelius. What was it? What was the evidence that these people had given? Something like this. Right? So Wegener also said, you can write this. In this, so under that point, the jigsaw fit you are writing, Wegener said that if we Sir, has the UPSC asked questions on the discontinuity taught yesterday? You should have checked. है ना राशि? आपको चेक करना चाहिए था. चेक करो एक बार और मुझे बताओ किया है कि नहीं. देखो पिछला 10-15 साल का पेपर, प्रीलिम्स पेपर, दिस इज योर वर्क ना, इट्स माय वर्क आल्सो, ठीक है, बट आई वांट यू टू डू दिस वर्क, करो, ये तो बेसिक वर्क है, यू कैन ऑलवेज गेट द क्वेश्चन पेपर फ्रॉम विजन आईएएस प्रीवियस ईयर क्वेश्चन पेपर्स, यूपीएससी क्वेश्चन पेपर, हमारा एक लिंक है, उस पर जाइए, ढूंढिए, मिलेगा आपको, एंड फाइंड आउट, देखते हैं, ठीक है। और सर नहीं पूछा तो पढ़ें क्यों, है ना, मे बी दैट्स योर नेक्स्ट क्वेश्चन, राशि बघेल, सर इफ दे हैव नॉट आस्क्ड व्हाई शुड आई स्टडी, मत पढ़ो। Am I forcing you? Am I forcing you to prepare for UPSC? We think it is useful, it is important, that's why we give. If UPSC has not asked, does it mean it will not ask? No. It can ask things which are relevant and we think this is relevant. Now it's up to you to figure out whether you want to, है ना, पढ़ना है नहीं पढ़ना, वो आप देखिए, ठीक है। और questions, I would expect you that after the class, this kind of work you people are doing. The ones who are serious are already doing, they are not asking, I know, ठीक है, they are not asking in for me that sir we are doing those questions, ठीक है। तो ये थोड़ा पूछने से आगे बढ़िए, खुद ढूंढिए, थोड़ा मोड़ा काम कीजिए अपने आप भी, ठीक है, ऑल ऑफ यू। सो Wagner said that if you take the margins of the continent and fit together, if you take the margins of the continent and fit together, the continents seem to fit, the continents seem to fit as pieces of a big part. Continents seem to fit as pieces of a big single part. Pieces of a big single part. And hence they must have been together in the past. Hence they must have been together in the past. The single big piece is what he called as Pangea. The single big piece is what he called as Pangea in his theory. Single big piece was called as Pangea in his theory. Okay. Then, next, second evidence. So, what are the second evidence given by Wagner? So, the second evidence that was given by Wagner was of similarities of rocks. Similarity of rocks. Similarities of rocks. Right. So Wagner also gave this evidence of the similarity of rocks. Now, what is this similarity of rocks evidence? Similarity of rocks means please see here and try to understand. Wagner said, right, he gave examples from different parts of the world. Okay, so he said that if we see the rocks of this part of West Africa and this part of South America, these rocks, and similarly rocks in other parts, this is one example, and he gave similar more examples, okay, from around the world. So he said that if we see these rocks or these rocks, we find that these rocks amongst them are similar. These rocks pairs are similar. Similar in, you can write this, right? So Wagner said, for example, or you can write, Wagner said, cut that for example. Wegener said that rocks on the nearby coasts, on different continents, nearby coasts on different continents have similarities in terms of age, chemical composition, structure, chemical composition, structure, and hence it seems that they were formed together. And hence it seems that they were formed together. For example, rocks of western coasts of Africa and the eastern coasts of South America. Western coasts of Africa and eastern coasts of South America as shown यहाँ पे, this one. Eastern coast of South America as shown. Okay. So something like this. Hence he said that they must have formed. Hence he said that they must have formed. Hence he said that they must have formed when the continents were joined together. Okay. For example, these rocks on African and South American coasts, are similar and formed around 2000 million years ago. These African and South American coasts are similar and formed 2000 million years ago. Also, Wegener also showed that the coastal deposits, the deposits in the coasts, coastal deposits between these two continents, is not older than nearly 150 million years ago. Not older than coastal deposits between these two continents is not older than nearly 150 million years ago. Which means these coasts were not formed before that. This is the coastal region. Okay, so the deposit on these coasts, this white line, are not older than 150 million years ago, which means these coasts are also not older than 150 million years ago. These coasts are also not older than 150 million years ago. Hence, there was no ocean in between. Hence, there was no ocean in between, which means they were together, which means they were joined together. No ocean in between, which means they were joined together. Okay. So this is how Wegener proved this second point. Then the third point in Wegener's story is of placer deposits. Placer deposits. Right? Placer deposit evidence. Right. So first we need to understand what are placer deposits, and then we'll try to go beyond. Okay. So first, what are placer deposits? What are placer deposits? First, we have to understand this, right? So I would expect you to draw the diagram with me. I'm drawing on the board. You can also draw simultaneously. Suppose you have a mountainous area like this. This is the mountain, empty, and this is the plain. Okay, and let us say in the mountainous area, there is some kind of rock minerals exposed on the surface. Some rock minerals are there. Rock minerals, right? Some rock minerals are there in huge quantity. And let us say that over this region, some kind of a river is also flowing. Right? Some river is flowing. River or water on a large scale is flowing. Right? Now, what will this river flow do to the minerals? It will erode and bring some of the minerals along with it. Right? This river will break the rocks and bring it down to the plains. And in the plains, it might deposit the minerals at some place. Right? It might deposit 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 rock minerals. And above we had the mines of rock minerals. So here we had the mines of rock minerals, okay, and the river is flowing over that, and this is brought and it is deposited here. So deposit of rock minerals. So this deposited rock minerals is what we call as deposited rock minerals called as placer deposits. Placer deposits. These deposited rock minerals are called as placer deposits. Okay. Rajneet Raj, what is meaning of matching of continents? Matching of continent means if you put two continents together, their coastlines fit together. That is called as matching. If you take a photo and tear it and then you put the photo pieces together, they fit together. So that is what match. So you can say those two pieces are matching together, and hence the whole photo is joined together as one. Same ways, matching of continents. Okay. So this is what we call as placer deposits. Is this okay? So basically what is happening in placer deposit? If you see in placer deposit, what is happening? The mine is somewhere else, mine from where it is coming is somewhere else, and it is deposited somewhere else. Right? Source is here, deposit is here. This is called as placer deposit. And what brings it from the source to the deposit? Any flowing medium like winds or rivers. Okay. So this is what we mean by placer deposit. Okay. Once we understand this, what is placer deposit? Now the evidence, the placer deposit evidence. Let us see. So you can write 1-2 line about placer deposit before we write the evidence. Hence, as seen in the placer deposit diagram, when the mineral source region is elsewhere, when the mineral's source region is elsewhere, as shown in the mountains, when the mineral source region is elsewhere, here shown in the mountains, and they are deposited somewhere else, here shown in the plains, carried by some medium like river, comma, then the deposited minerals carried by some medium like river, then the deposited minerals are called as placers. Next paragraph. Wegener gave the placer evidence. In the form of gold deposits, gold placer deposits found in the Gold Coast of Africa. Gold placer deposits found on the Gold Coast of Ghana, Africa. On the Gold Coast of Ghana, Africa. In Ghana, Africa, you have a gold coast. On that coast, gold placer deposits were found. Okay. Gold placer deposits were found. Gold Coast of Ghana, Africa. Full stop. But the source or mines of such gold, is not found anywhere nearby. But the source or mines of such gold is not found anywhere nearby. Full stop. On the other hand, on the Brazilian coast, gold mines are there. on the Brazilian coast. Here, this is South America in this diagram. So on the Brazilian coast, gold mines are there. On the Brazilian coast, gold mines are there. Here, somewhere here. Wegener said that these gold mines are the source of the placer deposits. These gold mines are the source of the placer deposit. And the placer deposits would have got deposited. Placer deposits would have got deposited when the continents were joined together. And the placer deposits would have deposited when the coasts were joined together, as suggested by Wegener. Coasts were joined together as suggested by Wegener. Okay, something like this. As suggested by Wegener. Right, so this is what the placer deposit given by placer evidence given by Wegener was. All right, so hopefully we get this placer evidence also. Right, the next evidence given by Wegener, you can write down the next evidence. So hopefully this is also understood, the placer evidence. Now the next evidence given by Wegener is the till deposit evidence, till deposits. Okay, so next evidence is the till deposit evidence. Till deposits, also known as tillites, also known as tillites. Okay, till deposits also known as tillites. So what are these till deposit or tillite evidences? Let us see. Okay, so first you have to write what are tillites. What are tillites? Okay, write down what are tillites. Technical team, classroom coordinator response पोर्टल नहीं दिख रहा है. क्लासरूम कोऑर्डिनेटर रिस्पांस पोर्टल. टेक्निकल टीम, क्लासरूम कोऑर्डिनेटर रिस्पांस पोर्टल ओपन कर दिए. Source of the placer deposits. Okay, so what are tillites? Tillites are, you can write, tillites are टेक्निकल टीम क्लासरूम कोऑर्डिनेटर पोर्टल नहीं दिख रहा है, प्लीज ओपन कर दिए. Coordinators, if you can hear me, please correspond to the technical team to open your coordinator portal on my screen. It is not visible to me. I think it is closed. So coming back, so tillites are the sediments carried, sediments or rock pieces, sediments or rock pieces carried by glaciers, carried by glaciers as they move over rock surfaces, as they move over rock surfaces over kilometers of distances. Full stop. These deposits or pieces get added to the glacier. Deposits and pieces get added to the glacier and move with the glaciers. Move with the glaciers, comma, and when the glaciers melt, these deposits or pieces get deposited on the floor. Get deposited on the floor or the surface over which glacier was moving. Full stop. Hence, by finding such deposits later on, we can say that in these regions earlier glaciers were present. These regions earlier glaciers were present. Full stop. Okay. Now, Wegener's evidence. Write down Wegener's evidence. Once we understand this, so then we take up Wegener's evidence. What evidence did Wegener give? Let us see. So what we find is, please see here. Wegener found, write down Wegener's evidence. Write down. Wegener found that in different climatic regions of the world, including equatorial, tropical, different climatic regions of the world, including equatorial, which means hot, tropical also hot, including equatorial, tropical, comma, tillite deposits were found. Tillite deposits were found. For example, in South America, see here, keep seeing also South America, this white region, southern parts of Africa and Madagascar, go on writing also. South America, southern part of Africa and Madagascar, these are hot regions, the Africa and Madagascar. Southern parts of Africa and Madagascar, peninsular India or southern India, and parts of Australia. Here. Also. He could not understand how glaciers, it could not be understood that how glaciers existed in these regions, but not the nearby other regions. How glaciers existed in these regions, but not the nearby other regions. As per the present position of the continents. as per the present position of the continents. As per the present position of the continents. Full stop. Wegener said that if we place the continents, Wegener said that if we place the continents as suggested by him, if we place the continents as suggested by him, with the Arctic pole, the Arctic region, with the Antarctic being at the southern pole, with the Antarctic being at the southern pole, with the Antarctic being at the southern pole, then all these till deposit regions, all these glacial till deposit regions. So this is the southern pole. I'm writing SP. Antarctic at the southern pole. This is the southern pole. Then all these till deposit regions will fall or will be fully within the polar circle, will be fully within the polar circle, and hence will be fully within the polar circle, and hence they must have experienced glaciers in the past simultaneously. They must have experienced glaciers in the past simultaneously. Must have experienced glaciers in the past simultaneously. So this is what he said, and hence they must have been together in the past. Hence the continents must have been together in the past. So this is the evidence he gave. Hence the continents must have been together in the past. Okay. Now we have to do another evidence, the fossil evidence, but I'll take break here. I'll give you a quick break. Okay, fossil evidence. So I'll give you a quick 15-minute break here. All right, and after that we'll do this fossil evidence and continue. Okay, so let us take a quick 15-minute break and then we continue from here. All right. Right. Sir, class pace is slow. Class pace is slow. There are 2-3 reasons for this. One, this is the beginning part and we are doing a technical, we are getting into a technical area gradually. So I want you to gradually grasp and go on reading. Over a period, obviously it will get faster. By the time the last classes will come, it will be pretty fast, right? But much before that. And the pace is not slow. I'm also keeping a track of the topics that we are covering and what is the pace from my side. This is how we go. Don't worry. ठीक है, आपको pace से ज़्यादा logic समझने में focus करिए. If you find time, if it is slow, that means you have time to revise, right? And reading further. So do it. Simultaneously पढ़ते रहो. Okay. Don't worry about the pace. You just focus on understanding. If things are understood, that is good enough, right? तो आपको पेस का ज़्यादा चिंता मत करिए, राइट, दैट विल टेक केयर ऑफ। ठीक है, और आपका तो अभी नया बैच है, अभी से ही पेस मिल रहा है, 2024 का बैच है, सो इट शुड बी दैट, हाँ सर ऐसा नहीं है कि टाइम है तो वी शुड वेस्ट, वी आर नॉट वेस्टिंग, डोंट वरी, ओके, वी आर परफेक्टली ऑन टाइम। सो गोइंग बैक, some of you might find it slow to that, sir, but then that's the pace of your class, okay, right? And that's how, because if I go faster then I keep getting doubts, lot many doubts come. Okay, the technical team, the classroom coordinators also get a lot of doubts. So either you show maturity by understanding fast, then we can go very fast. Okay, and then if you are in a very big class, then all of you have to adjust to the speed of the class. Okay. So coming back, now let us come to fossil evidence. So when we talk about this fossil evidence thing, okay, so what do we mean by the fossil evidences? Let us try to understand. Okay, so when we say fossil evidences, please see here and try to get 23, ठीक है, मतलब ठीक है, 21 में स्टार्ट हुए थे ना, तो मुझे नेक्स्ट ईयर लग रहा था, एनीवेज 23 का अच्छा अच्छा, सो आप लोग सोचो कि सर तो 24 का स्पीड पे चल रहा है, ऐसा नहीं है इतना भी। ओके, आई नो हमारा कौन कौन सा बैचेस चल रहा है, सो alright, so you still have time, but don't worry, come back and please focus here. So what was the fossil evidence? The fossil evidence was that Wegener collected fossil of these four major plants and animals. Write down the names, right? Cynognathus, Glossopteris, Lystrosaurus and Mesosaurus. ठीक है, सर के मुंह से एक गड़बड़ वर्ड निकला नहीं कि एकदम सारे अटैक कर दे दे सर, राइट? सो these four animals, write down their names: Glossopteris, Cynognathus, Lystrosaurus and Mesosaurus. Mesosaurus. Wegener collected the fossils of these four plants and animals from different parts of the continents. Different parts of different continents. Different parts of the different continents. Okay. And these places looked, and these places seemed random. And these places, please do write this also. Collected fossils from different parts of different continents, and these places looked random. These places looked random when seen according to present position of the continents. Seen according to present position of the continents. Present position of the continents. But Wegener said that if we place the continents, Wegener said that if we place the continents together, Wegener said that if we place the continents together as suggested by him, then we can see some kind of a pattern. Some kind of a pattern of movement of these animals. Some kind of pattern of movement of these animals. And plants being carried by them. Plants being carried by them with seeds stuck to their body. Seeds stuck in their body or in their food. That's how plants are carried. Seeds will stick to the body or in the food. Hence, Wegener said that these continents must have been together. Only then these plants and animals would have moved across. These continents must have been together. Only then these continents would have moved across. Full stop. Okay. Then lastly, write down. Wegener also used paleomagnetic evidence which means paleo means old, magnetic, ancient, the old magnetism, which means old magnetism, old magnetism of the earth of millions of years ago. The ancient magnetism of the earth of millions of years ago. So what was the magnetism of the earth millions of years ago? Paleomagnetic evidence. Paleomagnetic means the ancient magnetism of the earth millions of years ago. Where I'll just dictate this, right, in 2 lines, and you should be writing this much in your answer. That's it. You don't need to get into details. They won't get into the details of these questions, I assure you. Okay? Where the magnetic character of minerals, of old minerals, magnetic character of old minerals on the continents, magnetic character of old minerals on the continents, magnetic character of old minerals on the continents is used to find the direction of movement of the continents. Is used to find the direction of movements of the continent. How is beyond the syllabus, so I won't get into that. Okay, so just this line, where the old magnetic minerals are used to understand the movements of the continents. Okay. So this is these were the evidences used by Wegener. So 6 evidences used by Wegener we have written. All right. Now, after the evidences, once we understand all these evidences, what was the next thing? Once we get this evidences, the other thing is, so these were the evidences used by Wegener to prove his theory. The last part is forces responsible. This is the next subheading. Forces responsible for continent drifting. Forces responsible for continent drifting. Which were the forces responsible for continent drifting? This was the last part explained by Wegener. Forces responsible for continent drifting. Okay. Now there was a question. I think Amit sir, you have put. Vaibhav ने लिखा है. how the Tethys Sea was formed. I have said Tethys Sea was formed when Laurasia broke from the Pangaea and Laurasia started moving northward. So in between gap was there. That was the Tethys Sea. Okay, Vaibhav. I'm sure Amit sir must have said the same, or coordinators must have told you this. Okay, so anyways, coming back. So forces responsible for continental drift. First, we need to understand what were the direction of movements suggested by Wegener. Okay. So we can see, I hope you can see in your theory that Wegener said continents drifted northward and westward. These were the only two movements that Wegener talked of, northward and westward. Okay. So the continents drifted northward and westward as per Wegener. Okay. Right. Jigsaw fit, similarity of rocks, placer deposits, till deposits, fossil evidence and पैलियोमैग्नेटिक एविडेंस. आस्था थोड़ा ध्यान से देखिए. ठीक है. So continent drift northward and westward. So what were the cause given by Wegener? The cause given for northward drift was the polar fleeing force. The cause for northward drift was polar fleeing force, and the cause for westward drift was the tidal force. So these were the two causes given by Wegener for the movement of the continents. Right? So two forces were given by Wegener to be responsible for the movements of the continents. Right? Please do write first of these, then these first, and then we'll discuss. So northward because of polar fleeing force and westward because of tidal force. Okay. Once you have written this, northward and westward because of polar fleeing force and tidal force, first we have to understand. Then we have to understand what is polar fleeing force and what is tidal force. First, let me make you understand what is polar fleeing force. Okay. So when we talk of this polar fleeing force, please see here, polar fleeing force. First we understand what is polar fleeing force. When we talk of the polar fleeing force, let us say, first understand it. So let us say we have a stick like this. Okay, इधर एक stick बनाया हुआ है मैंने. And let us say from the top of the stick I'm hanging a thread. Okay, some thread is hanging from the top of the stick. And at the bottom of the stick I put a weight. Something heavy, some ball or some bead I'm hanging. After that, I am spinning this stick, Okay, spinning this stick like this, taking in my hand and spinning the stick very fast. Let us say by some mechanism, I'm putting it on something and then spinning it. If I will spin the stick, then what will happen? As the stick will spin, the thread will extend and the ball will go to the corner, and this will also go on rotating around. I hope you understand this. So the ball has risen high and it has started rotating around, right, due to the centrifugal kind of a force. Right, so the ball has risen high first, gone against the gravity by rising, and it is rotating around fast, something like this. Okay, so I hope this much is clear. Now Wegener used a similar thing, and he said that the earth is like this. This is the orbit of rotation of the earth. The earth rotates like this around this orbit. Okay, and he said that the continents, let us say they are stuck on the surface of the earth. Initially they were stuck at the bottom near the South Pole like this. All the continents were stuck at the bottom like this. And then the earth was rotating. As the earth was rotating, and the continents were stuck, but they could move on the surface. They were stuck in such a manner that they will not fall off and they are not permanently fixed at the place. They could move on the surface of the earth, right? So continents were there on the ocean floor. Below is the ocean floor, ocean rocks. The continents are stuck on it, but the continents can move on it. So basically, as the earth will rotate, these continents will try to go out due to centrifugal force. Because of this continent started moving outwards. All these continents started going outward, so that centrifugal force, because of this rotation, it is like magnets stuck to an iron ball and hanging bottom. So if you spin that ball, what will happen? All those magnets will try to go out and they will move on the surface and reach the upper part. So this is how the continents are moving, and gradually they reached to northern parts, something like this. The continents were drifting like this and they moved, something like this. Okay. So ultimately, because of this, the continents have drifted and they are running away from pole. This is the south pole. All these continents are drifting away from the south pole. South pole. So he called it as polar fleeing force. Flee matlab run away. So he said that the continents are running away from the pole, and hence he called it as polar fleeing force. Do we get it? So now write this down. Write this down. As per Wegener, you are writing the polar fleeing force. As per Wegener, the continents were movable over the ocean floor. Movable over the ocean floor. And initially, continents were movable over the ocean floor and initially all collected near the South Pole. Initially all collected near the South Pole. And due to the rotation of the earth, and hence the centrifugal effect, rotation of the earth and hence the centrifugal effect, the continents, in an attempt to move out, comma, moved northward towards the equator. Moved northward towards the equator from the South Pole. This is what Wegener called as polar fleeing force. This is what Wegener called as polar fleeing force. Polar fleeing force. Polar fleeing force. Okay, then. Now, the second. What is the second force? The second one is tidal force. Okay, so tidal force. Put the next heading, tidal force. First, write tides. What are tides? Tides are created in the oceans Tides are created in the ocean due to the gravitational attraction of sun or moon. Due to the gravitational attraction of sun or moon. Also, during tides, the normal ocean water level the normal ocean water level tends to bulge in the direction of the sun or moon, tends to bulge in the direction of the sun or moon, and also the opposite direction. Also in opposite direction, rising by a few meters, rising by a few meters or feet. Hence creating a bulge. Hence creating a bulge over the ocean known as the tidal bulge. Known as the tidal bulge. So, the tidal bulge remains fixed towards the sun or moon. Tidal bulge remains fixed towards the sun or moon, though the earth rotates west to east. Earth rotates west to east with respect to the sun or moon. Earth rotates west to east with respect to the sun or moon. Hence, the tidal bulge or the tide, hence the tidal bulge or the tide in the ocean moves east to west. Tidal bulge or the tides in the ocean move east to west. East to west with respect to Earth. Tides move east to west with respect to the Earth. Full stop. Right? So the tide bulge will move east to west with respect to the Earth. Hence, Wegener said that this westward moving tide was pushing the continents westward. Was pushing some continents westward. Westward moving tides were pushing the continents westward. Okay. So what was the cause? So this is the tidal force that he said was the cause of the westward movement. So he explained both. Now, next paragraph. So I hope you understand the westward and the eastward then. Sir, why only Antarctica stuck in southern pole? Wegener did not explain. Okay, Wegener did not explain why Antarctica only stuck at the southern pole. And later on, when you will read plate tectonic theory, you will realize that all these were the weaknesses of Wegener's theory. Okay, so don't worry. So write down next line. Though Wegener did try to explain the causes of plate movement, continent movements. Wegener did try to explain the causes of continent movement, but his explanations but his explanation and forces were wrong. Explanation and forces were wrong. And hence these were the weaknesses of his theory. These were the weaknesses of his theory. Weaknesses of his theory. Okay, but Wegener's theory did rightly identified that the continents are drifting. That at least the continents are drifting. That at least the continents are drifting. This much he was right. Okay. Please watch the video of tides again. I will not explain. Okay. And the tidal bulge once formed moves. ठीक है. So वो वीडियो अभी यहाँ से फिर से देख लीजिए rather than me explaining again. So this is the continental drift theory. Okay, so you can write this much. Wegener, continue one last line. Wegener tried to improve his theory. Till his death in 1930. Till his death in 1930. So in 1930 he died. Okay, and till then he tried to improve his theory. Then, next paragraph. In the 1930s, Arthur Holmes, this was after the death of Wegener. Arthur Holmes came up with the convection current theory. So next theory we are coming to. Convection current theory. For the Earth's mantle. For the Earth's mantle region. So he said that in the Earth's mantle region there is a convection current. Okay. So now we come to this theory, second theory. Wegener's theory is over. Now let us come to the Arthur Holmes convection current theory for Earth's mantle region. Okay. Now what was this convection current theory of Earth's mantle region? Let us try to understand, which will help us further gradually go beyond. Okay. So we'll gradually understand with this the next. So we'll go on understanding gradually through theories that what is the real thing happening on the Earth. Every theory was trying to explain something. They had some mistakes, they had some right things. Okay, Wegener theory had some right things, some wrong things, which we will understand when we'll go to the next theory. Next theory will say this was wrong in the previous theory and this is the right thing. Okay, then that new theory might also have some wrong things. Next theory will improve it. Okay, so this is how theories keep coming and they keep improving our understanding. Okay. So what is convection current theory? Let us try to understand. First, we have to understand what are convections. What are convections? Okay. So convections, what are convections? Let us first try to understand that. What are convections? Please see on the board and try to draw with me and simultaneously understand. In any moving object, convections are created in moving objects. Right? So convections are created in moving material. Moving, something that can move. Convections are created in movable material. And we know that in the mantle, the asthenosphere is a movable plastic material. It is hard, but it is like plastic. Under pressure, it can bend and move. Okay, so we know that in the mantle, there is some material. The magma is in a movable solid state. Movable. It can move. It is solid, but it can move. Movable solid state. Right? So are created in movable material. How? Please see. I'll give the example of water to make you understand. Suppose you have water, a container. Container is there, and in the container you have some liquid filled in the form of water. Okay, you have liquid filled in the container. Yes, right. You have some liquid filled, and let us say that below the in the container you have also put some flame. Not in the container, you have put the container on flame. There is high fire or heat or fire from below. Okay, then what will happen in the liquid? Some liquid is there. So what will happen in this liquid? You will see that the liquid will start getting heated in the center. Heats and rise. Heats up and rise. Right? The liquid heats up and rise. Then it goes on the surface, cools down, comes down. Okay. So heats and rise, and on the side cools and comes down. Okay. And then it will complete a cycle like this. Whole cycle is completed. Right? So this complete movement, this complete movement is called convection movement. Heat convection movement. Call it as the heat convection movement. This is what your heat convections are. Okay, so this is what we mean by heat convections. Hopefully you have done this, everyone. Heat convection movements. Right? I do understand some of you science background students would feel, sir, आपको heat convection समझाने में, you know, why are you explaining so much? This is for your whole class. In your class, there are many art students. They might have forgotten what are heat convections. So it is for them. Right? And don't worry, you people might find these classes to be going slow. Same ways they will find the history and the, you know, polity and other classes to be going slow. They will say, why is sir explaining so much? Right? Now that is because science students generally don't have that background in polity and history and other things. You know? So balance ho jayega. Don't worry. This is how classes go. Right? Especially if the mix is of science and non-science and all kind of students. So don't worry. Come back. So this is what your heat convection. Hopefully done. Now, next, the convections in the mantle. So heat convections in the mantle. Next subheading. How do we get the heat convections in the mantle? Let us see. So heat convections in the mantle, I'll just show you a diagram. Heat convections in the mantle are somewhat like this. It will come, don't worry, just a moment. Some voltage fluctuations. Right? So this is how heat convections in the mantle take place. Okay. So this is the mantle region. We have also written asthenosphere. Now what is happening here? You can see this whole loop moving in the mantle or the asthenosphere, this region. They have shown up to a depth of 700 kilometers. This is why I told you up to a depth of 700 kilometers, those convections or the asthenosphere extends. Okay. So the convection like this. And what is the cause of the heat? It is said, so Arthur Holmes said that the cause of this heat is the radioactive material which might be present at the place where the convections are rising. Some radioactive material might be present inside the earth. At different places, different material is present. So radioactive material might be present in the interior of the earth. From there, the heat is there. Because of that, the convection is rising. And the convection is going like this. Then it is going below the lithosphere and it is spreading below the lithosphere like this. Then it cools down gradually because the lithosphere is cold. The rocky region is cooler. So it cools down gradually, passing the heat to that, and then gradually comes down. So this is how the whole cycle or the whole movement is completed. Can you see this? There is one convection zone, and same ways in the interior of the earth there are many convections. Okay. The remaining things you have to forget. All the other things drawn, you don't have to keep in focus. You just have to focus on that convection in this diagram. Okay. This diagram is given in the plate tectonic handout, which is uploaded on your platform. The plate tectonic handout. Okay. So this is what he meant by the convections in the mantle. Right. Now the diagram for convection in the mantle. I hope this is clear first. So then you can draw the diagram. Either you can draw this simple thing or you can draw a simple just the lithosphere and below that the convection. That's it in the mantle. Okay. So just complete this simple diagram. ये कोर आउटर कोर इनर कोर ये सब जरूरत नहीं है सिर्फ कोर लिख दीजिए गुड इनफ जस्ट राइट कोर देयर ओके so write down that as per Arthur Holmes as per Arthur Holmes as per Arthur Holmes in the earth's mantle in the earth's mantle large convections are created large convections are created large convections are created due to the presence of due to the presence of radioactive material inside the earth's interior right something like this radioactive material in the earth's interior which cause the heating of the asthenosphere magma and the convection. Which cause the heating of the magma and the asthenosphere heat convections. Asthenosphere heat convections. Okay. Actually, these are the cause. Actually, these convections. Actually, these asthenosphere convections. Write this way. Actually, these asthenosphere convections are the real cause of the movement. Asthenosphere convections are the real cause of the movement of the surface of the earth. Surface of the earth. And this was explained by the later theories of seafloor spreading, and plate tectonics. Seafloor spreading and plate tectonics, as discussed later. Right? So this is your end of Arthur Holmes theory also. Right? So Arthur Holmes theory explained. Next subheading. After the Arthur Holmes theory of the 1930s, during the Second World War period, during the Second World War period, there were extensive ocean floor studies conducted. Extensive ocean floor studies conducted. Ocean floor studies conducted so as to figure out mostly about the sunken ships, so as to figure out mostly about the sunken ships of the Second World War period. Full stop. Till that time, it was assumed that the ocean floor was a abyssal plain. Ocean floor was a flat abyssal plain. Ocean floor was a flat abyssal plain having nothing over its flat rocky surface. Flat abyssal plain having nothing over its flat rocky surface. As shown. As shown. And I want you to draw this. Sea level, ocean, abyssal plain, right? Which one is the abyssal plain in this diagram? This is the abyssal plain. This one, abyssal plain and ocean. So we had the ocean, the sea level, and the abyssal plain. Relief of the ocean basin as understood before Second World War. Just draw this. Okay. Simple diagram, just draw it fast. Now, once you've drawn this, then write. But the extensive ocean floor studies revealed a completely different picture of the ocean floor. Revealed a completely different picture of the ocean floor. Revealed a completely different picture of the ocean floor. And it showed that the abyssal plain was not as flat and without any other major formations as understood earlier. Rather, there were many major formations on the ocean floor. There were many major formations on the ocean floor. As discussed below. Okay. So, please see this diagram. Hopefully this one is done. Now see this diagram. So, I will hide another part of this diagram which is not needed here. And I want you to focus on this diagram, right? Okay, so I just want you to focus on this diagram and see the different parts, and if possible draw also, right? What do you find? You start from here. This part is the coast. This is the coast. From the coast, and this line, that above line is the black line, is the sea level, water level, the water level of the ocean. So from the coast, first you have slight region which is slightly below the water. Okay, slightly below the water, and flat. It is flat, called as continental shelf. Why? Because it is part of the continent which is below the ocean water. So continental shelf. Then there is slight sloping, more sloping region called as continental slope. Okay, continental slope. And on the margin, somewhere here is the continental rise, where the continents are rising from. So from here the continent is rising upwards. So continental rise. So continental shelf, continental slope, continental rise. Three parts which are below the water. All these three parts together, continental shelf, slope and rise, are together called as, these three regions are together called as continental margin. Continental margin. They are together called as continental margin. These three regions, continental shelf, slope and rise, together are called as continental margin. Why? Because they are the margin of the continent which is below water. They are part of the continent below water. So this is the coast, continent, land, then continental shelf, continental slope, gentle sloping more, and then rise up to here. After this, you have a deep point like this called as trench. This is the trench. Okay, this deep point is your trench. So somewhere here you have a deep cut called as trench. What trench? Trench near continental margin. Please go on drawing. Trench near continental margin. Then you have the plain. This is the abyssal plain now. Only these parts are abyssal plains. Then you have the guyot, flat on top. You have a ridge, pointed on top. You have an island, not necessarily volcanic island. So I'll rub the word volcanic from there. We have an island seen here. So island, again trench, but this is trench in open ocean. Trench in open ocean, that is trench near continental margin. So trench in open ocean, again a deep point, and then you have mid-oceanic ridge, this whole thing. What is the mid-oceanic ridge? Mid-oceanic ridge is the whole thing, not only one line, but the whole thing is called as mid-oceanic ridge. So I'll just point what is the mid-oceanic ridge in this diagram. This whole thing is the mid-oceanic ridge, whole, which is upward sloping, and in this you have the central fault. Okay, so just draw this. Okay. And we have to write about it also. So continental shelf, write down continental shelf. I'll slowly dictate also, and in between I'll give you time to draw also. Continental shelf are part of the continent, submerged near the coast, part of the continent submerged near the coast, submerged near the coast. Abyssal plain, abyss means very low. Abyss plain means flat plain, low plain. Near the coast, part of the continent submerged near the coast. Having a gentle slope, of less than 1 degree. Less than 1 degree. So very gentle slope. Less than 1 degree. Then beyond the continental shelf is the continental slope. Beyond the continental shelf is the continental slope, part of the continent. Continental slope, part of the continent. Continental slope, part of the continent, submerged below water. Submerged below water. Having a slope of 2 to 5 degrees. Having a slope of 2 to 5 degrees. Continental slope goes down. Continental slope goes down up to continental rise. Continental slope goes down up to continental rise, which is nearly the end point of continent. Nearly the end point of continent. In the ocean. Full stop. The shelf, slope and rise. Shelf, slope and rise are together called as shelf, slope and rise are together called as continental margin. are together called as continental margin. Which is the part of continent? Which is the part of continent crust submerged below ocean water? Part of continent crust submerged below ocean water. Submerged below ocean water. Full stop. Okay. So this is your this. Then next. Then we get many times. Not always. We get many times deep trenches on the ocean floor. Deep trenches on the ocean floor, which can be near the margin, which can be next to the continental margin. Deep trenches on the ocean floor, which can be next to the continental margin. Or can be much far from the continents, or can be much far from the continent margin, or can be much far from the continent margin located in open oceans. These two. Much far from the open continent margin located in the open ocean. These trenches are like big cracks on the floor. Big cracks on the floor. Crack on the floor. Vertically deep by few kilometers. Vertically deep by few kilometers. 3, 5, 6 kilometers, 7 kilometers. Vertically deep by few kilometers. So varies. It can be as deep as 3 or 5 or 6 or 7 kilometers. And cracking the surface for hundreds of kilometers. Cracking the surface on the surface of the land, ocean floor, cracking the surface for hundreds of kilometers. Then next, on the ocean floor, we also get ridges which are like peaks, which are like hill peaks. Ridges or sea mount. We also call them as sea mount. S-E-A-M-O-U-N-T. Mountain in the sea. Sea mount. Ridges or sea mount which are like hill peaks. Ridges or sea mount which are like hill peaks. Hill peaks. Or flat top mountains due to erosion. Flat top mountains due to erosion, known as guyots. Known as guyots. Known as guyots. G-U-Y-O-T. Guyots. If the ridges rise above ocean water, if the ridges rise above ocean waters, we call them islands. We call them islands. If the ridges rise above ocean water, we call them islands. Islands. above ocean water, we call them islands. Full stop. Call them islands. Full stop. We might also get mid-oceanic ridges. Mid-oceanic ridges. We might also get mid-oceanic ridges. Mid-oceanic ridges, which are like big mountain chains. Big, long. Rather than big, you write long, which are like long mountain chains. Many mountains, one after the other, like Himalayas. Much longer than Himalayas, which are like long mountain chains, not very high. Long mountain chains, not very high. Height is very less, up to 200, 300 meters only. But they will be very long, hundreds or thousands of kilometers long. Long mountain chains, thousands and thousands of kilometer long. Long mountain chains, not very high, only up to 250 2.5 kilometers, not 250 meters, only up to 2.5 kilometers high. Not very high, only 2.5 kilometers high. Long mountain chains having cracks on their top. I would expect Arjun and Nidhi to send your doubts to the classroom coordinators. They would be answering. Okay. Please send. Shivam, you also. Having cracks on their top, known as central fault. Known as central fault, which are normally volcanically active. The central fault is normally volcanically active. Central fault, which are normally volcanically active. The central faults are normally volcanically active. Okay. Trenches are not always there between the margin and this thing. I said many times. I didn't say always. Okay. निधि ध्यान से सुनिए. Also, generally all the other flat ocean floor, generally all the other flat ocean floor, generally all the other flat ocean floor is called as abyssal plain. Is called as abyssal plain. All the other flat ocean floor is called as abyssal plain. Normally having a depth of around 4.5 kilometers. That is the depth of the abyssal plain. Normally having a depth of around 4.5 kilometers from the sea level, top sea level. 4.5 kilometers from the sea level on an average. On an average. Hence, we see that ocean floor has many features. Ocean floor has many features. The formation of which we will gradually understand in the next theories. The formation of which we will gradually understand in the next theories. Seafloor spreading theory and continental plate tectonic theory. Okay. Next theories. Formation of which we will see in the next theories. Right, so this is where the class ends today. Next class we continue from here. All right. and we'll see the other things. So next parts we'll continue from here. Okay, that's it. This is where the class ends. I give you last 1 or 2 minutes to draw this diagram. In the meantime, I think most of you have understood what we have done till now. Classroom coordinators, I don't think there are any major doubts you want me to take up. So that's it. Thank you everyone. Next class we continue from here. Okay. What are flat topped ridges? They are flat because of erosion. I've said, ध्यान से सुनिए, अभी आपने लिखा भी है कॉपी में, flat topped. Due to erosion, they become flat on the top. Okay, so that's it. The class gets over. Thank you everyone. Next class we continue from here and we'll go. Module if we have time. Do we go through vision module if we have time? Not needed here. Just do the NCRTs. Okay, and what we are doing in the class. Just do that much. That is good enough. No relevant queries. So there might be some irrelevant queries. Amit sir, I can understand. Students, I would expect you to ask only things which are more relevant to the exam. आगे के questions मत पूछिए अभी. Do the things which are presently there. Yeah, NCRTs you should do. Okay, so that's it. Thank you everyone. I would end the class. Technical team, class over. Shukriya.